Hi everyone, and welcome to Backer Breaks It Down. Today we look at short-run behavior of polynomials with a focus on trinomials. Okay, so short-run behavior all has to do with your roots. We want to find the roots of our polynomial functions. So how do we do that? Okay, so we can determine the short-run behavior of a polynomial by writing it in its intercept/factored form. Okay. Now, the values of x for which the polynomial equals 0, these are the zeros. So like, for example, if I have a linear factor, so that's a factor of the form x minus k, then the polynomial has a 0 at x equals k, because if you take the factor and you set the factor equal to 0 and you solve, that's how you're figuring out your x-intercepts, or your zeros of your polynomial functions, okay? So trinomials, I call this type the easy case. Simply because it's like 1x squared. That's what makes it so easy. So we simply want to find the factors of c, the constant term, that add up to be the middle term. And then we'll write it as a product of two binomials. So for example, x squared plus 5x minus 24, I want to know what multiplies to be negative 24 and adds to be 5. And what I get is positive 8 and negative 3. So then I write those factors as a product of two binomials. So x plus 8 for the positive 8, x minus 3 for the negative 3. So if you have a trinomial and there is a quadratic coefficient, honestly, is it a common factor? Definitely look and see if it's a common factor first, okay? And then if it's not, then we can factor this trinomial using either something called the D-FOIL AC method or something called the box method. Now, both of these start off the same way, okay? So with both of these, I want to multiply the first and last two terms, and I want to find the factors that multiply to be this and that add to be the middle term. Okay, and so I can make a little X box where I organize that information. Okay, the AC method takes these two factors that you find, okay, and you want to replace the middle term with these factors. Okay, so you're going to get rid of the b times x, you're going to put in these two factors, and then you're going to factor by grouping. Okay. The box method organizes things a little bit differently. So after you find those two factors, you draw a 2 by 2 square. And you're putting the first term in the upper left-hand corner, and you're putting the constant term in the lower right-hand corner. And then the two factors go in the remaining boxes. Okay. And then you simply want to find the greatest common factor of each row and each column, and these will give you your two binomials. So here's a side-by-side comparison of the two. First two steps are the same. So we multiply the first and last terms. So we get negative 21, and the middle term is negative 4. And we want to find the factors that add to be that middle term, multiply to be negative 21. So we get negative 7 and 3. Okay, those two steps are the same. Okay, for the D-FOIL method, we want to replace the middle term with these factors. So notice goodbye negative 4x, hello, negative 7x plus 3x. Okay, and we're factoring by grouping. So we group the first two terms, we group the last two terms, we take the common factor out of each group. Notice what's in parentheses is one of your factors, what you took out is the other factor. Okay, for the box method, so after you figured out what your two factors are, they're going to go in these two boxes here. So you got your first term, your last term, your factor. And then it's just all about taking out the GCF from each row. So that 3x squared at negative 7x has a greatest common factor of x. 3x squared at negative 7 has a greatest common factor of 1. And then I'm going to take out the greatest common factor from each column. So 3x squared and 3x has a GCF of 3x. Negative 7x and negative 7 have a GCF of negative 7. Okay, notice that those greatest common factors are your two factors. So the box method, I feel, organize it a lot nicer. You can easily see what your two factors are, as opposed to like over here, many students like struggle with seeing what the two factors are with the AC method. Okay, but you should really use the method that works for you, right, when you're factoring. Now, because we're working with polynomials, you know what that means is that we can go beyond x squared, okay? So like, what if you had something that's quadratic in form? So x to the fourth plus bx squared plus c, or ax to the fourth plus bx squared plus c. If you recognize how the expression factors in its original form, then do so. So what they mean when they say like in its original form is like this one here, x to the fourth minus 7, x squared minus 18. Like, what would you do if it was just like x squared minus 7x minus 18, right? So, like, you'd be like, well, what multiplies to be negative 18? And what adds to be the middle term of negative 7? Okay, so you would find those two factors, and that's what they did. They said negative 9 and 2. Okay, so notice what is different here. What's different here is here they wrote x squared minus 9 and x squared plus 2 because it's an x to the fourth situation, and we have to like accommodate for that. Okay. Be on a lookout for differences of two squares, because then you can factor them further, so the x squared minus 9 can be factored further. Okay. But honestly, think about the simpler equivalent and how you would factor it. Okay. So let's take a look at some examples, all right? So you want to factor these polynomials. So remember, what's the first step when we factor? That's right, greatest common factor. So I look at number 6 here, f of x equals 4x cubed minus 5x squared minus 9x. I see that all three of those terms have a common factor of x. So I'm going to take that out, write down what's left over. So if I divide everything by x, I get 4x squared minus 5x minus 9. Okay, don't go losing that common factor. I'm going to make an answer line, put the common factor on the answer line, because honestly, it's going to get ignored. Okay, so I can use either the AC method or the box method. Regardless, first two steps are the same. So 4 times negative 9 is negative 36. And I want to know what multiplies to be negative 36 that adds to be negative 5. This right here is the hardest step when you're factoring. So let's see, I can go 9 times 4 in order to get negative 36. Whoops, this would have to be negative 9. Negative 9 plus 4 is negative 5, so it all checks out. Now me, ever since I've discovered box method, it's honestly my preferred method, so I'm going to use that. So I'm going to have 4x squared, right? That's the first thing I write down in my box. And then the constant term goes in that last box. Negative 9 and 4 are going to go in the other two boxes, and honestly, it doesn't matter where. Okay. And so now I'm going to take out the greatest common factor of each row and each column. So looking at that first row, I have 4x squared minus 9x. I have a greatest common factor of x. In the second row, 4x and negative 9, that is the greatest common factor of 1. Okay, now I'm going to find the greatest common factors of my columns. So 4x squared and 4x has a greatest common factor of 4x. Negative 9x and negative 9 has a greatest common factor of negative 9. So in addition to my common factor of x that I have on my answer line there, I also have the factor x plus 1 and the factor 4x minus 9. So this would be the factored form of my polynomial function. Now I'm going to use the zero product property to find the zeros of my function. And so the zero product property says take each factor, set it equal to 0, and solve. So any factor with an x you need to do this with. So this x factor out here has a 0 of 0. X plus 1 would have a 0 of negative 1. 4x minus 9 would have a 0 of 9 over 4. So my zeros are 0, negative 1, 9/4. So in this one here, we want to factor to write it in intercept form. And what's the first step when we factor? That's right, common factor. So when I look here, I have a common factor of -1. That's it. What's left over is x to the 4th minus 13x squared plus 36, right? So don't be freaked out here just because it's x to the 4th. That's okay. We're still going to approach this the way we approach other quadratics. We're going to be like, well, what multiplies to be positive 36 and adds to be -13? Okay, so -9 times -4. Okay, so this is an easy case because it's simply x to the 4th, right? So that means I'm going to have x squared minus 9 and x squared minus 4. And both of these are differences of two squares. So I'm going to break them down even more. X squared minus 9 will become x plus 3, x minus 3. And x squared minus 4 will be x plus 2, x minus 2. And so then all that's left for me to do is to find my zeros using that zero product property. So if I set each factor equal to 0 and solve, I'll get positive and -3 and positive and -2. So we can find the short run behavior of polynomials by writing the polynomial function in its factored form. Okay, and then we're like, well, where does the polynomial equal 0? Because those are how we find our zeros, our x-intercepts. So we're simply going to take our factors, set them equal to 0, and solve. And that's how Becker breaks it down.